Lesson 25. Understand plane sections of prisms and pyramids. Lesson objectives, content objectives. Students will be able to describe the intersection of a plane and a right rectangular prism. Students will be able to describe the intersection of a plane and a right rectangular pyramid. Students will be able to describe the intersection of a plane parallel to the base of a cone or cylinder. Students will be able to understand that intersections may be parallel, perpendicular, or neither parallel nor perpendicular to the base of the solid. Language objectives. I can read to explore different ways to form cross sections by slicing through a three-dimensional figure. I can make conjectures to discuss with a partner or small group how a cube can be sliced to form a hexagonal cross section. I can explain how to slice a pyramid to form a square-shaped cross section using terms such as parallel, perpendicular, base, and vertex. I can demonstrate understanding of the term cross-section by labeling models. Prerequisite skills. Identify two-dimension figures. Identify right rectangular prisms and pyramids. Know and use mathematical language to describe attributes of plane figures and solids. Recognize parallel, perpendicular, and intersecting lines. Lesson vocabulary. Cross-section. A two-dimensional shape that is exposed by making a straight cut through a section of a three-dimensional figure. Review the following key terms. Plane. A two-dimensional surface that extends infinitely in all directions. Vertex. The point where two rays, lines, or line segments meet to form an angle. Learning progression. In grade 6, students were introduced to a right rectangular prisms and pyramids and learned to decompose these three-dimensional figures into two-dimensional shapes that make up the faces of the figure. In this lesson, students connect their knowledge of two- and three-dimensional figures to describe cross-sections of right rectangular prisms and pyramids. Slicing three-dimensional figures helps students develop three-dimensional visualization skills and extend their spatial reasoning skills. In grade 8, students expand on these concepts and apply them to cylinders, cones, and spheres. Composition and decomposition of shapes continues to be used throughout geometry from grade 6 to high school and beyond as students become more sophisticated in applying strategies and formulas for areas and volumes to the solution of real-world and mathematical problems. Let's think it through. What is a cross-section of a three-dimensional figure? You can think about a cross-section as a slice through a three-dimensional figure. Picture slicing a cube made up of clay with a string. The two-dimensional shape that you get is called a cross-section. When you slice through a cube, one of the shapes that you could get is a triangle, just like shown here. When you slice through it, you can get a triangle. It just depends on the angle of the slice. A three-dimensional figure can have many different cross-sections. It all depends on the direction or angle of the slice. We just talked about that. So think about how this was sliced, okay, to create that triangle. Think. Different slices through a rectangular prism create different shapes. Okay. One way to slice a rectangular prism is with a plane parallel to the base of the prism, just like shown. See how this plane is parallel to the base? Therefore, this cross-section will be a rectangle. Another way to slice a rectangular prism is with a plane perpendicular to the base of the prism. Okay, just perpendicular to that. And again, this will be a rectangle. The slice could also look like this. It doesn't have to be parallel or perpendicular to a face of the prism. See how it cuts at an angle, a certain angle? Okay. Think. Different slices to a rectangular pyramid create different shapes. The slice can be parallel to the base, perpendicular to the base, or a completely different angle. One way to slice a rectangular pyramid is with a plane parallel to the base of the pyramid, just like this one. Another way to slice a rectangular pyramid is with a plane perpendicular to the base. If the plane goes through the top vertex, the slice could look like this. If the plane is perpendicular to the base, but doesn't go through the top vertex, the slice could look like this. Think about what shape this is. Think about what shape this is. Think about what shape this is. The slice doesn't have to be parallel or perpendicular to a face of the pyramid. It could look like this. Think about this shape. Can everybody see that? Okay. Let's reflect. What are some different shapes that you can get when you slice a rectangular prism or a rectangular pyramid? Please explain. So if you're not sure, you can go back to this in this video and you can listen to the video again. Take your time. Solve this question. Once you're done, unpause the video and then you can check your answer. Here's a possible answer. You can get triangles, squares, trapezoids, parallelograms, and rectangles. And again, when you go back in this video, you can see the two dimensionals of triangles, squares, trapezoids, parallelograms, and rectangles.